Hello, welcome to Air Gauging Basics, a webinar about our length measurement systems. I'm your presenter, George Schutz, the Director of Precision Gauges here at MAR Incorporated in Providence, Rhode Island. The objectives for this webinar are to understand why air gauging is a valuable dimensional measurement solution. It'll help provide an understanding to air gauge theory, and we'll learn about some of the applications for air gauging. And we'll get you the information needed to provide an air gauge solution to meet the customer's requirements. Air gauging was first sold and developed in the 1940s. It's the first truly high-performance tool for the shop floor, bringing 50 microinches or 1 micron or better measurements to the point of manufacture. And it's even more important today as tolerances are getting tighter and tighter. Why use air gauging? Well, air gauging is a measurement system that allows for fast measurement. Because the plug is made to the bore being measured, it's self-aligning. There's little operator influence with an air gauge. It gives you high performance. Again, 0.1 microns or 5 microinches. It's a non-contact system. It's using back pressure as the measuring medium, so it won't mar the part that's being measured. And because air is passing through the tool, it tends to clean away any surface contamination. When do we like to use air gauging? Well, when tolerances are tight, no less than plus or minus 40 microns, or plus or minus 1,000th and a half of part tolerance. These are good applications for air gauging. Because it's a variable gauging system, it lets us know the deviation from the nominal size. So it tells us not only if the part is good or bad, but it also tells us how good or bad the part is. Because it's a fast measuring system with minimal operator influence, it's a great tool for measuring a high volume of parts very accurately and quickly. But we can also use it for a geometric measurement, not only high volumes, but if a part is too big for another means to get a tight tolerance dimension, say like a large aircraft transmission housing where there's some large diameters, well, that part might be very valuable, and air gauging might be the right solution for that. But measuring geometric conditions like taper, straightness, and center distance are also great applications for air gauging. Or if we're at the point of manufacture where the environment is dirty, air gauging is a good tool for that also. Is air gauging difficult to apply? Well, not really. Air gauging is often no different than selecting an adjustable bore gauge, a fixed mechanical plug, or even a snap gauge. You need to know the same information. What's the size? What's the tolerance? Where is the measurement being made? And in the air gauging world, we also like to know what the surface finish of the part is. This is very important. Air gauging is made for the application. It's made to a specific size. So if there was a mistake in specifying the tooling, it could result in an unusable measuring system. So it's important to get the information right when applying air gauging. So what are the principles of air gauging? Well, air gauging works on back pressure. So if you think of taking a garden hose full of water and holding it against the wall of a building, what happens? The closer and closer you get, the spray gets spread out to the side, and eventually you're going to close off that nozzle. And two things are happening there. You're closing off the distance, and the pressure in the hose is building up. And we kind of use that same type of back pressure or flow for air gauging. In the case of the water flowing through the hose or the air flowing through an air tool, the further you get away from the surface that you're measuring, the flow is the bigger. And the closest you are, the flow is the smallest. The opposite happens with air pressure. When that jet is closed off or that nozzle is closed off, the hose sees the highest pressure, and the further away you get from the surface you're measuring, the pressure gets less. So we use these pressure distance curves to measure with air gauging. You restrict the flow, or you restrict the nozzle, you have the highest pressure. You open up the nozzle, you have the lowest pressure. So we can use that. Now, if you plotted those things out, you would see that pressure distance curve, and you would see that there's a nice straight position or portion of that curve, which is the linear area, and that's the area that we can use for our pressure distance measuring system. But it all comes down to the jet, that little orifice that's in the air tool. Usually in a air plug, there's two of them. It's a two-jet system. And when the air flows through that and it's restricted by the surface being measured, it builds up that back pressure. So as the air jet is restricted, we are measuring what is happening to the air in the system. We're measuring really the back pressure. Now, when we control the air pressure, the manufacture and position of the air jet, the manufacture of the air plug, and we can calibrate that system to a pneumatic zero, we can create a curve that's very repeatable. And this is the basis for all MAR air gauge systems. Thus, the results can be used to make measurements with that back pressure on a display and get some very good results. And this is what MAR does when we make an air gauging system. We control all the components of the system: the air plug, the air display, and the master. And to go one step further, MAR uses a balanced air system. We don't just measure the back pressure through the restriction. What we do is we create a balanced air system which has a reference leg. So as the air comes in through the filter, through the regulator, it's broken up into two legs: a reference leg and the measuring leg where the air tooling is at. And what we do is we compare the reference channel to the measuring channel and look at that difference. That's what's actually giving us the measure. And this eliminates any small changes in air pressure that could affect the measurement results. Now, we said an air system consists of the air tooling, it consists of the readout system, and the master. And MAR manufactures those three components and gives us a fast measuring system that's easy to use, highly accurate, you get good resolution, it's non-contact, and it's ideal for working in the shop environment. And I'll start looking at those three portions of the air system, the components. And the air tool is probably the most critical component in the air gauge system. It establishes the reference from which the part dimension is compared to. So what makes up that air plug or the air tool? Well, the air tool is nothing more than a hardened steel cylinder with some air passages and opposed jets. The air goes through the plug and comes out through those jets. And the proximity of the part to the jet throttles the airflow, resulting in pressure changes. And an air gauge instrument measures that pressure and displays the part size. Now you saw that the air jet is a small hole, and that hole is basically about 1 millimeter, a little bit more, of 50 thousandths of an inch in diameter. So the air flow comes out those jets, and we said that the part throttles those jets to give us the back pressure. Now, air has to fill in those peaks and valleys if that surface on that part is rough to give us our back pressure. So if that surface is very rough, we're actually over the diameter of the jet going to have to fill in that area of the peaks and valleys. If that surface is too rough, we might see a little bit of offset. Now you can imagine that a contact gauging system is only going to ride on the high parts or the peaks of our surface. So if the surface is rough, we might get a deviation between an air gauge system and a contact probe system. So that's why we like to know what the surface finish of the part is, just to ensure that we get good correlation between the different types of measuring systems. So if you're measuring a tight tolerance, it's important to know and understand the surface finish of the part. Now, air plugs are, again, by far the most common used air gauges, and with their 2-point measuring system or 2 jets, we can measure the diameter of a hole. But by exploring the hole, rotating the plug, and moving the plug axially along that bore, we can look for things like ovality, barrel shape, taper, or even hourglass shape within that part. So making dynamic measurements, you can know what's going on with your boards. Now, plugs come in various ranges of body styles and so forth. Typically, I said they're 2 jet systems, but you can put those jets in the middle of the plug or at the end of the plug to make us a through jet system, or a blind, or even a super blind air plug to get really close to the bottom of the bore. We can also make plugs that have very long lengths, a continuous body length, for example, to go over steps or land within a bore. We can even add stop collars to ensure that the jets land at a specific depth or on a short land. We mentioned most plugs have 2 jets, but we can also have a 3-jet plug when we know that there's a form error, an odd number of lobes in that part. A 3-jet air plug will allow us to find that odd lobe condition. Or we can add 4 or 6 jets and come up with averaging of the bore diameter. A 4-jet plug will average a even lobe condition, where a 6-jet will give us an average of 2 and 3 lobe roundness condition. So the number of jets can give us more information about the diameter of the part. Now we can also make air tooling to measure ODs. You can get air rings with configurations for 2 or 3 jets. You can put the jets at various locations from the face of the air ring, and you can make that air ring either a bench or a portable measurement solution. And then you can also make air snaps for measuring ODs on the part as they're being manufactured. And of course, you can get single or multiple circuit configurations in air snaps. And like I said, it's often used at the point of manufacture on the machine tool while that part is still being manufactured. Probably the greatest feature about air gauging is the jet itself, the sensor. It's very small and they can be positioned very close together. There's probably no other sensor that can do this at the cost or within the small area of an air plug. Typically, jets can be put at as close as 0.1 inches together, but sometimes they can be even closer. So this provides us the capability of doing multiple dimensions or geometric checks in a single tool. No other sensor has the capability of doing that. at this type of cost. So tapers are a great application for air gauging because we can measure two diameters in a very small hole at a known distance and calculate the taper angle. And where are tapers used? Well, they're used for machine tools, for holding the spindles in place. Oh, they're also used in the medical industry. All your hips, shoulder components, those are all locked together using locking tapers. And often they are very small, less than a half-inch diameter, for example, but we can make air tooling to measure those tapers. And then once you have the tooling, you need some type of display option. And whether that be a mechanical dimensionaire, our portable micro dimensionaire, column gauges, our N1700 PC with cockpit software, or full-blown gauging computer applications, we have a number of display options to be used and provide the results the customer needs. Now, when we're talking about air tooling, again, you have to know the size, the tolerance, the location of the dimension being measured, the surface finish, form conditions, the display, and the master being required. And MAR manufactures all these components, the masters, the type of display, and the air tooling. So we know the whole air system and we build the accuracy into each one of those components. And when you're using air gauging, there's some things to be considered to get the best and most reliable measurement. Air gauging is very stable, but again, it's always good practice to verify the zero position occasionally. Again, this is based on the number of parts and the critical nature of the tolerance, and also the environment. We want to make sure that there's no temperature expansion going on. The air pressure in the air tooling is sufficient to remove liquid contamination from the parts, but it's always wise to clean the part before it's being measured. The same thing with the master. The master and the workpiece should be at the same temperature. We don't want to get a part off the machine while it's still warm and measure that. Let it stabilize a little bit and ensure that it's at room temperature. So we want to remove any of the non-fluid dirt from the part, so wipe the part. And it's also a good practice when the air plug is bench mounted to rotate it every now and then to minimize wear. We recommend that the jet should be at the 3 or 9 position and then rotate them occasionally to ensure that the plug body is not being worn. No, we say that air tooling is a non-contact system. Well, it's a non-contact system for the sensors making the measurement, but still the body of the plug is going to touch the part, and if you're measuring hundreds or thousands or even millions apart, it's good to rotate the plug so that it gets even wear. So why choose MAR for your air gauging needs? Well, MAR has the experience and the application know-how. We've made millions of different designs of plugs over the years, and we know air tooling because we build the accuracy into it. We build the accuracy into not only the tooling, but also display, and we also manufacture the masters. So we know accuracy since we make all the parts of the measuring system. So in this short time, we've covered air gauging, learned that it's been around since the 40s. It allows for fast, highly accurate, minimum operator influence measuring. Air gauging is ideal for many ID and OD type of measurement and is specifically built for the application. Very specific information must be gathered from the user regarding the workpiece that's being measured. It's important to have that information because the tooling is custom made to the application, and we want to get it right the first time. MAR has the experience and expertise to be your #1 choice to solve your customers or your measurement problems. So thank you for participating. We hope you enjoyed this webinar.